So I'm basically going to be going right into the chat and then popping in to look at questions every few minutes. Does that work for everyone? Yeah, we're already 15 minutes in. I'll like to start. Okay, cool. Well, I linked the slides in the YouTube chat. So if anyone has questions, go ahead and put them in the YouTube channel. I'm going to keep checking in every now and then on those questions. So if it's about some specific concept or some specific slide, I'll try to kind of keep up with them periodically throughout the chat. Sound good? I like how I'm talking like I could hear you all, but that's great. Okay, let's get to this. Okay, so the topic of today's kind of discussion, if you will, is called functionalist programming in Python. So quick thing, like why do I care about this? Who am I? So my name's Lorena, and I run PyLadies Chicago. I do a lot of things with Python. I'm on the Python Software Foundation board. So if you have questions or if there's topics that you want to learn more about or specific education initiatives that you would like to participate in, please reach out. I'm more than happy to chat with anyone after the fact. And I hope to also answer some questions today about this topic and about other things that PyLadies does itself. So let's get into it, a little bit on functional programming. So the idea of functional programming, what exactly does that mean? So given these two different code examples, we've got two different methods. So let's take a look at this first one. So nothing too exotic. It's called add2. It looks as if that it takes one input, something named number, and if you look at it, it's making use of Python globals. So it's going to be adding to a Python global variable named number. So nothing too exciting, but this could be one way perhaps we write some logic to add to some variable out there in our program. Okay, so that's one little code snippet. The second little code snippet is this class right here. So imagine we have something called an inbox. So maybe we've got some initialize method that sets up some state. Perhaps it's got a queue, perhaps it's got a finite number of messages it can process, but broadly speaking, it's an inbox. It's a thing that receives messages and does things with messages. So we've got this kind of code right here. It's called process messages. So nothing too exciting, except that we see that what we will be doing in this method is we will pop off a message from the queue, and then with that message, we're going to go ahead and process. Meaning we may do some work like pull some data from a database, send some emails, something along the lines of that kind of idea. So that's great. We've got two different code snippets. Why do I care about this? Well, let's delve a little further. So the first thing I wanted to point out is this idea of side effects. So when we talk about side effects, we want to think a little bit not only about what's happening within the method itself, but what's happening as a result of the code, the work that's being executed inside of our methods. So if we were to go back to the idea of these two methods, what can we say are the side effects that is in the language that Chris Jenkins provides us when we call this function? What does it need that isn't in the argument list, and what does it do that isn't part of the return value? So we saw that we've got these two methods, and in the add2, we know we've got some global variable named number. So this function, while it does take an input, it does have this side effect of mutating the value of this global variable named number. So we could say the side effect of add2 is that it changes the state of this global variable number. Let's take a look at the inbox code again. So we can say, what is the side effect of process messages? Well, what we see is that we know we're pulling a message off a queue, but this process logic, granted we don't have a lot filled out here, but we can assume that process is changing something about the inner kind of state of inbox itself. So maybe it's changing the number of messages that are in the queue. Maybe it's got some blocking IO call that is being tracked inside of inbox. But basically what we have here, these two code snippets, are two different pieces of code that are impacting other parts of your code base, and that's going to be broadly kind of understood as this idea of side effects. Again, the idea that the only thing that's being changed is not going to be solely defined to the input list and the return value, but there may be other side effects of code that may be changed given the way that we've written our code. So why do I care about that? Well, the big thing about functional programming that we really want to kind of reconceptualize is this idea of how we write our code. So in functional programming, it's a paradigm that thinks of writing code as treating functions as pure mathematical computations. The biggie here is that it doesn't permit shared state or immutable data. So if we're looking at our code snippets here, we would say that this is not exactly very functionalist kind of code, because we've got some side effects that's changing some state of the world as a whole. So be it the global variable or be it the state of inbox itself, the object. These functions don't just do some pure computation. They actually alter other areas of our code that may not be explicitly clear by just reading the definitions that we have here alone. So I'm going to pause, and still no audio for me. Okay. Okay. Hey Mo, I responded to your question. Could you let me know if you, I guess if you don't have audio, it would be difficult. Yes, audio is clear when you click on the link. I'm not quite sure what that means, Ben, but I'm going to go ahead and keep trucking along. Okay. So, just a disclaimer of what today will be. We're going to do some light review of some concepts that will help us understand what functional programming is and how we can see some of these paradigms at play in Python. We won't be doing a deep dive. We won't be going into comparing all the different coding paradigms out there, but we will be talking about some language that you can use when you start describing functional code and how we can see that in Python. So back to our great code example. So if we were to say that the above example is not operating within this functional paradigm, the idea that we treat functions as purely computational constructs, we can say that perhaps the second example is something closer to that. It's very clear to us that given an input, we're going to execute this logic, which basically says, take this input and add 2 to it. So now we've kind of broken up the impact of what this code is doing to other code around it. It's not going to have the side effect of changing something out there. Instead, it's only going to be doing the explicit directions here as defined in the method body. So functional programming, I kind of got a kick out of this a little bit. The way I really started getting into functional programming, or rather trying to kind of understand it, was when I saw a bunch of people around me it's talking about Scala, Java 8 with the streaming API, talking about Haskell, talking about Lisp. And it kind of made me laugh because when I started researching a little bit more about the movement back and forth in different coding paradigms, I was very excited to see that functional programming wasn't new, but it's something that people are getting excited about again. So in my mind, it kind of just goes to show that with these paradigms, they may rise or fall in popularity, but perhaps they don't always go away. So like I was saying, functional programming isn't new. You may hear some language like declarative or imperative styles of programming. When we say declarative, again, the emphasis here is that we're writing our code explicitly more like, not like subroutines, but rather we're giving a set of explicit directions that can be run over and over. So in the concept of functional programming, we will have something that takes an input, does some stuff, and returns a value. And that right there is going to be a declaration of what that code is doing. So if you hear things like imperative or declarative, this is kind of an early fork in the road when we start organizing some of our coding languages. So functional programming draws its roots from lambda calculus, which I believe was started in the 1930s. It was meant to study concepts like recursion, functional applications, etc., etc. Some languages that you may hear that are functionalist, that are just basically functional programming languages, are things like Lisp and Haskell. So as you can see, Lisp is 1950s, Haskell 1990. So while this may not be a new paradigm, you may see that people take different approaches on it as they write their languages that may or may not be static. So why do we care about functional programming? So as we kind of saw, we right away were able to move from perhaps code that has impacts in other places that may not be clear to just having logic that lives in one place, that function. So we get to remove the complexity of side effects. If, depending on how you like to write code, you can argue that functional code is easier to read because you can understand what's happening by seeing what the function takes in and what it returns. So if you're thinking about this from a testing perspective, perhaps you have some calls to some external services and it's unclear when, back to the inbox example, maybe as you're processing messages, you're changing some counters elsewhere and that may not be exactly clear to you what other things are changing as you're processing messages. So if you were going to try to go and test some of this code, rather than mocking out the service that you make these calls to where you're consuming messages in from the queue, perhaps you have to read a much larger code base to find out all the different areas you have to mock. So I kind of thought this was a nice description of it when it says if it produces the right answer today, it will produce the right answer tomorrow. So generally speaking, it seems to be that there's a consensus that functional programming results in shorter code and is less error prone. So we say a language is functional if it supports and encourages programming without side effects. So the big question, right, is Python a functional programming language? Well, sort of. We wouldn't be able to have this fun discussion if it was as straightforward as perhaps yes, right? So what functional programming features does Python support? Well, one way we can think of Python as being a functional, or rather supporting this idea of functional programming, is we can think of first-class functions. So one of the things I like to kind of read about is like the blogs or the interviews that Guido has given over time, or, reading I'm starting to read more of the PEP standards. But I thought this was kind of a nice encapsulation of what it means when we talk about first class. So Guido was interviewed at one point and said, one of my goals for Python was to make it so that all objects were first class. By this, I meant that I wanted all objects that could be named in the language, such as integers, strings, functions, etc., to have equal status. That is, they can be assigned to variables, placed in lists, stored in dictionaries, passed as arguments, and so forth. So when we say functions are first class, we're saying that they have all the capabilities of other entities in the programming language. All right, cool. I'm going to pause for a moment. Okay. Okay, cool. So looks like no questions yet, so I'm going to keep trucking along. Okay. So let's think about this. So again, we want the idea that we can store functions and variables, we can store them in different objects like dictionaries, and we can pass them around as arguments. So if I had this really exciting code snippet, we got three different functions. We have one that says meow, we have one that says woof, and then we have one that says make sound. So they're not very exciting. Basically, the two sounds are going to return some string with a phrase, and the method make sound is going to take a type, and given the type, it's going to then make that sound. So if we were to do something as simple as create a dictionary, store as keys the type as a string, and then the functions as a value, we can then say, okay, cool. Grab me the associated value based on the type and return that from make sound. So right away we see here with this code snippet that we're able to meet some of these basic requirements that Gita was outlining. We can store functions inside of dictionaries, we can return them from methods, and if you look at this example at the bottom, so make sound, if we provide a type cat, what that's going to do is it's going to return the meow function, and then it will take in the grr phrase to create the exciting phrase meow, meow, grr. And if you're curious, if you think I'm losing my mind about how to spell meow, meow is how you actually spell it in Japanese. So I thought that was cute. So okay, cool. So we see some of this idea of being a first-class citizen, if you will, for functions in this code snippet. Well, what else? Okay, cool. So I love empanadas, and I'm always thinking about them. So let's take a look at this first code snippet. So if we were to create a method that just will return a class empanada with a time and a type, what we can see here is a very simple code example, but again, we can store this function in a variable and do a thing with it. Or if you want to think a little bit more about treating functions perhaps as variables maybe used in iteration, we have this example here. So we've got two functions, English, Spanish. They're going to return a greeting in that language. So we could say for greeting in and English, Spanish. So right now we're treating the functions as variables, and then we're able to, as we iterate, go ahead and evaluate them. And in case you didn't get the feeling of how functions act as first-class citizens, let's take a look at some more examples. So we've got a function capitalize all words, and we've got one called text modifier. So in this code snippet, something that we're doing that we haven't done before is actually treating a function as a input. So we are able to pass in the modifier and, given a phrase, modify that string based on how that procedure is defined in the modifier. So in this case, we just capitalize all the words in the phrase and we return it 3 times. Or we print it 3 times. Okay, so first thing Python does is we're able to treat functions as first-class citizens. We can store them in variables, we can store them in other objects, we can treat them as inputs for other functions. So that's kind of cool. But what else? And I'm gonna pause. Okay, cool, no questions. All right, so higher order functions. That's cool. What does that mean? So I thought this was a really, really great demonstration of some of the things we're going to talk about in a moment. So this gentleman, he said, if I had to illustrate, map, filter, reduce in a tweet, how would I do it? So if you haven't used these, the idea of map is that you have some collection and then some instructions for how you want to map those instructions to each item in your collection. Filter is pretty straightforward, means filter items out that don't meet this requirement that I'm going to specify. And reduce, I think, is pretty simple. You're going to reduce a collection into some singular entity based on the instructions you provide. So in this example, we see that the given emoji counts, if we think cook is what we would expect it, but if you had corn, cow, and chicken, and then you say I want to cook these items, then they would be mapped to popcorn, a hamburger, and perhaps, I think that's like a omelet. I'm not actually sure. So, you know, in this example here, we're seeing some of this idea of higher order functions that we're going to define in a moment. Speaking of which, I thought it was kind of cute because in the filter, I was confused when I saw the egg because as a non-vegetarian, I was not sure if people eat eggs or not. So I responded and said, I think your filter may be a bit busted, and immediately got back this response basically saying there's different types of being a vegetarian. So I'm not sure if Steven is a person who demonstrates programming concepts with illustrations often, but this is very, very transparent, I think, with this example, what these three things do. Okay, so when we say higher order functions, what we're saying is that these are functions that can accept functions as input, and can even return them. So that's cool. So back to the map, filter, and reduce. What we see here, in theory, we're guessing that cook is vegetarian or eat may indeed be a function, and then we have a collection. So we see with map, filter, and reduce that it is indeed accepting a function and a collection and doing a thing with it and returning a value. So this does fit the definition of a higher order function. But let's actually get into some Python code to see what that looks like. But first, back to the benevolent dictator for life. It was very interesting to me because if you weren't aware, but in Python 3, there was a lot of discussion about if reduce should be removed. And I wasn't exactly sure like what was going on there. So kind of perusing around on some blogs, I found some language that Guido gave when he was talking about this. So he said about 12 years ago, Python acquired lambda, reduce, filter, and map, courtesy of, I believe, a Lisp hacker who missed them and submitted working patches. But despite the PR value, I think these features should be cut from Python 3. So right there, that's kind of interesting, right? So we see these higher order functions were actually introduced by someone, I guess, who's a Lisp hacker. And we know that Lisp is a functional programming language. So it's kind of interesting. This gives us a little bit more insight into the kind of paradigms that Python has and what the creator of Python actually thinks the language ought to be. So kind of unclear still what we arrive at with Python. So how can we see higher order functions at work in Python? There's a really great library called FuncTools. So if you haven't used it, there's great documentation, and I think, I actually didn't link it. A fair amount of these images are actually linkable, so you can actually go through to the library or to the blog post that I pulled some of the stuff from. But Functools is basically a library for higher order functions in Python. It includes functions like reduce, wraps, partials, etc. So what's that mean? So for those of you who know what a decorator is, and I'm going to pause and ask, does anyone not know what a decorator is? Okay, so for the sake of simplicity, I'm going to define a decorator as a way for you to kind of create like a subtype, if you will, without having to extend a class. So you see here wraps, again, a function defined in Functools. If we wanted to use it, what does it actually give us? So we see we've got this first function, get permission or for. So we're guessing that this does some application logic to find out if this user has some permission to do a thing. We then have this next function called require permission. And this is where wraps comes in. So you'll see it's annotated like a decorator with the @ symbol. And we have an inner function called wrapper. So inside of this inner function, we've got this try except. And you'll notice that you have to try to get the permission. If you don't have permission, I'm guessing that maybe get permission will raise an exception if permission isn't there. Granted, that's probably not the best way to write your code, but for the sake of argument, let's say that's how it works. You'll see that if you do have permission, then you can go ahead and then call that function f, which is the input for the outermost function require permission. You then also return the wrapper from require permissions. And if we wanted to think about how to use this, we could, in the bottom, perhaps write some functionality like order food. The inputs for that would be a user, whatever food you want to get, but you'll notice it's annotated with the require permission, decorator. So essentially what this is doing, require permission takes function f, and function f will be order food. So order food, again, back to this idea of higher order functions, require permission as a function takes a function, which is order food. It's passed down. Using the wraps functionality from Functools, we're able to associate it with this wrapper. And actually, wraps is a shorthand for update wrapper. I believe that's the name of it. Yeah, update wrapper. But using the wraps functionality, we're able to specify directions. Basically, we say, before we allow this person to order food, let's make sure they have permissions to do the thing. Otherwise, we're going to go ahead and raise an exception. So this is one example of how we may see higher order functions working in Python. What about partial? So this blog post is pretty great. It goes into more detail about partials, but I lifted this example from there. And basically, partials, if we were to look at this example here, we'll see that again, we define a method that does a thing. So in this case, we have a method called power. It takes two inputs, base and exponent, and it does what we think it does. It raises that base to that exponent. So if we were to use partial, you'll see that partial takes in a function and then takes in some arguments. So if we were to think about this as partial, notice that it's only taking in partial or some of the inputs, not all of the inputs, when you first register this function called square or this function called cube. Instead, when you call these partial functions, you will pass the remainder of these inputs to that function to execute the logic defined in the function that's provided as the first argument. So again, we've got something where we have a function taking a function as an input, and with a little bit different functionality where it's not taking all the inputs, but rather some of the inputs, you are able then to create some more dynamic programming concepts or constructs. So if you've like kind of poked around a little bit in functional programming, one of the terms I kept coming across was this idea of currying. And I wasn't exactly sure what that was, but the big takeaway, and we'll look at it a little bit more in a second, is I want to emphasize that Python partials aren't the same as currying. So what in the world is currying? Okay, so currying is a way where we can take a function and break it up into a series of n functions. So let's say we have 5 inputs. We might write an outermost function that takes the 5 inputs, but then it returns a function that actually uses 4 of those inputs. And then that nested function will return a function that takes 3 of the inputs. And you just kind of keep going down until you've written functions that work with each of the functions, or each of the inputs. So the idea here is, while you might have something similar to partial, where we are providing just partial of the inputs when we first register this other function, like square cube, it's not exactly the same. And how can we kind of demonstrate what that means? So if we were to have this example where we can think of add as just adding together two numbers. Maybe there's nothing more exotic to it than that, but we'll presume that's what add does. If we were saying we're going to do this with partial, what happens when we go ahead and use partial? Again, we provided the input as, the first input will be the function that has the logic, and then the second would be a partial subset of the inputs that you want to do, and then when you actually call F2, you will provide the remaining inputs. Well, the idea with currying, if you kind of see here, currying would take the actual logic, so in this case add, as its sole input, and then you would create some function like called F2. Then F2 would take the first input, and then you get a third function, and then that third function would take the remainder of the inputs. But the idea here is partial. Partial is a little bit more like a more manual process, whereas currying has a more granular level of isolating each input as you chain together these instructions to do a thing. So if you come across currying and you're reading a little bit more about that, you can think of it as a way of taking a complex routine and breaking it into a subset of different functions that act on partials of the input that you'll be using to compute a thing. Okay, cool. So we looked again at partial, at wraps. These are both part of func tools, and we know that Guido has some mixed feelings on these higher order functions, and we know that allegedly they come from some Lisp hacker out there in the world. So back to that first tweet, if we wanted to see how reduce, map, and filter work, we'll talk about Lambda in a moment, but basically reduce takes a set of instructions for how it's going to go ahead and reduce the second input to some singular entity. Map, how are you going to map all the elements in a collection to something different? Filter, how am I going to remove the things in my collection that don't meet the requirements I specify? So lambdas are anonymous functions. And the idea here is, rather than me writing def, add numbers, return x plus y, I can use a lambda, and thinking back to lambda and knowing that lambda calculus was something that had a heavy hand in inspiring functional programming, we say that there's some legacy of lambdas in Python. But generically, you can have more than one argument. They'll be comma separated, and you will then use a colon to separate the arguments from the instructions of what you want to do with the arguments. So in the first example, we've got two inputs, X and Y, and the instructions are add X and Y. So if we were to kind of think about a collection that has values 1 to 6, we would say 1 plus 2 is 3, 3 plus 3 is 6, and so on and so forth. Cool. And as you see, reduce is now part of Func tools. Okay, so I'm going to pause, see if anyone has any questions. Okay, cool. Doesn't look like it. Okay. So one of the things I like to do is pull data from the interweb and try to aggregate it to surface cool projects I like. So this Almost Funded is some code I wrote where basically I go out there and I crawl some social giving platforms and I try to find projects in specific categories and say, hey, these are within, I believe it's 10% of their total fundraising goal. Let's help them get funded. So it's not the most exotic thing in the world, but it's a fun little project. So why am I talking about this? Well, let's take a look at some code I actually wrote. So we've got this scraper called Kickstarter scraper, and we've got a class function, and we see that we can specify a query, and we can say, do we want to paginate? So this is a stripped down version of some of the code I have, but we make a request, we get some data, and then what we want to do is we want to filter that. So again, using that filter, I'm able to say, get me only the things that are with that are 90% above 90% of their fundraising goal. Once I have those, I want to go ahead and map each of these projects into whatever respective project serializer that they ought to be. I've got a factory here. So filter, map, lambda, some cool stuff. So if this is how I may do it in a functionalist or functional-ish approach, what would it look like if I did it a different way? Well, actually Guido is a big fan of, as we know, the Zen of Python. To be explicit is better than implicit, but really the big thing with Python is we very much aspire to write code that's easy to read. That's what Python's very much known for. It's got white space. We really emphasize having clarity. And for him, he thinks that doing list comprehensions, which can afford the same functionality as map and filter, is indeed easier to read. So again, back to the filter. Rather than do a filter here, I can do a list comprehension that says if this is with above 90%, go ahead and keep that project. And then for mapping, this is something I can say for PM projects, just actually go ahead and throw it into the factory and give me what I need. So 2 ways to kind of approach this, but we see that Python supports them both. Okay, so we have functions as first-class citizens. We have higher order functions. What about lazy evaluation? So something that I came across was this paper by John Hughes on why functional programming matters. It was kind of interesting. He talks about writing tic-tac-toe as basically 2 functions. One that can create a tree of all the possible states of the game, or like all the moves you can make given what you have currently on the board. And then you would have another function that actually consumes the first one to go ahead and play the game. So thinking of this as, thinking about writing a tic-tac-toe program as just 2 functions, one that can generate all of the possible moves you can make given the moves that have been made, and then the other one which will consume it. So back to this idea of a function taking a function as input, kind of made my head spin a little bit, because it seems like that would be like a lot of work to do that and could get very complicated very quick. And if functional programming is supposed to be more more transparent, because you know you explicitly know the inputs, you know what's going to be returned, we don't encourage side effects. How is this any better? Well, with lazy evaluation, basically what John Hughes was saying is that instead what we can do is we can go ahead, rather than having to generate all the possible moves right at the start of the program, we can go ahead and make that computation when it's needed, as it's needed. So rather than us having to do like infinite loops to go ahead and generate all these possible outputs, we can instead have a list of all these possible moves that once a move has been made, we can compute the next possible move. So with lazy evaluation, the idea is kind of a call it as you need it. So how do we see this in Python? So there's a really nifty library called itertools. You get a bunch of different things in it, but here's a good example. So itertools.izip, we provide, we've got a list with values A, B, C, and we have a tuple with the numeric values 1, 2, 3. So when we think of zip, we know we're gonna go ahead and zip the 0 to the 0, the 1 to the 1, etc., etc. But actually this implementation in Python, if you were to go look in the itertools documentation, specifies that this uses lazy evaluation. It's not going to actually do the work until it's required to. So another way we see this are generators. So we can think of a generator perhaps as for x in range 5 million, let's compute x divided by 2. So this range value here, we don't actually create a list with all the values in it. We actually only call the number once we arrive at that number to go ahead and do that computation. Another way you can think of generators is how we've written it here with the yield keyword. So if we did like the method call below, print divide by 2 and provide an upper bound as the input, what we see here is that yield is going to go ahead and it's going to, excuse me, it's going to go ahead and pause, and actually only at that yield keyword, only then is it going to go ahead and then make the computation that it needs to figure out the value of num currently. So if num is 0 and then we have 1, when we say yield num divided by 2, we're actually saying pause, let's make the computation to find out the value of num, and let's do a thing. So on Stack Overflow, I think someone had a really good, suggested a good definition of what generators are, which is basically that it's a list that stores all elements when it's created, whereas a generator generates the next element when it's needed. So rather than doing all the work up front, you're going to iteratively going to process and do work, and then when you need that next element, at that point in time, will you then go ahead and do the computation to get that element that you need. So while a list can be iterated over and over, a generator can only be iterated over exactly once. With a list, you have an index. A generator, you do not have an index, because you only make that computation on the fly. You're not actually recording. You're not actually recording and holding. Back to the idea of range 5 million. We're not actually creating a list in memory and saying store the values from 0 all the way up to 5 million. So where does this leave us at the end of the day? We've talked about Python and how Guido really has kind of mixed feelings on the contributions of higher order functions. We saw some of his preference for doing list comprehensions over using higher order functions. And we saw that in some capacity, we've got this idea of functionalish programming because we do have functions as first-class citizens. We do have higher order functions, and we do also support this idea of lazy evaluation. So at the end of the day, I think if we were to try to sum up what kind of language Python is, I think we would say it's multi-paradigm. There's capacities to introduce some of these concepts of imperative programming into Python, but we also know that we can write object-oriented programming in Python. So again, back to our benevolent dictator for life. Guido basically says, I'm not a fan of religiously taking some idea to the extreme, and I try to be pragmatic in my design choices. But not too pragmatic. See the start of this sentence. So again, he's emphasizing that he values readability and its usefulness for real code. So the key point here, he says, there may be some times when map and filter will make sense, but for other places, Python has list comprehensions. So I think, you know, this is just a nice kind of soft introduction into some of the influences of what Python kind of set out to do at the start. And really, we see that people have added things over time, and how has that changed? How has that changed Python's identity? If you want to read more, there's a great book by David Mertz called Functional Programming in Python. It's an O'Reilly's book. It's great. That will give you clearly a much more deep dive. I recently read 7 Languages in 7 Weeks by Bruce Tate. And while Python isn't covered, you do talk about languages like IO, Scala, Ruby's kind of thrown in there as, there was a little discussion of why Python or why Ruby, and he chose to do Ruby, which I think is fine. But again, it was a nice introduction into the different paradigms we see in these languages and how, you know, given the problem space you're in, maybe this is better or maybe this is worse. And then, of course, the functional how-to docs that Python has. This is pretty great. So I'm going to go ahead and pop that open. But yeah, so this is kind of what I've been using. It gives some definition of like what a declarative language is, what is a functional programming language, you know, why do functional programming, and how does Python support it. So we talked a little bit about itertools and generators. You can do some more deep dive on iterators here. And there's a generator section. But yeah, passing values into generators. So yeah, while we only kind of talked about it briefly, you can definitely do a deep dive into this. And Mary Cook, I was kind of poking around her blog. I really appreciate it because she did, she demonstrates a lot of functional programming concepts actually using Python, which is pretty cool. And there's a bunch of other links that I have throughout this presentation, including all the way at the beginning. This Chris Jenkins piece, that one's pretty awesome. So this is where I turn it back over to you all. So any questions, please feel free to ask in the room. Thanks for being really patient. I really appreciate it. If you do have other questions and you would like to reach out to me on Twitter, I'm there as well. And my personal website, lorenamesa.com. I have a mechanism for being able to reach me on there as well. Okay, so I'm going to see if anyone has any questions. Nothing? All right. Well, I'll tweet out the slides again, and please do reach out to me. Technology problems aside, I want to make sure that if anyone does have anything they want further information on, or perhaps want more resources on, I would love to help facilitate that. Thank you, everyone.